Welcome students to online classes of mathematics for class 9th. In this video we are going to study the chapter number 6, which is lines and angles of NCERT textbook, and we will try to cover the exercise 6.2. This is session number 3 for this particular chapter. Myself Deepak Gautam, TGT Mathematics in Kendriya Vidyalaya Sangathan. So let's start with today's class. The first topic that we are going to study is parallel lines and a transversal. Okay, so before that, first you should know what is a transversal. So simply, a transversal is a line which intersect two or more lines at distinct points is called transversal. Okay, it is a line which intersect two or more lines at distinct means different points. Okay, is called transversal. Like you can see here, we have two lines, this M and N. This L is the transversal to them because this line L is passing through these two lines and cutting it to distinct point. Okay, so this line L is the transversal to the line M and N. So here L is transversal to the line M and N. Okay, L is the transversal to the line M and N. Okay, so when a line or a transversal falls on two parallel lines, here in this case this line M and N are parallel. Okay, and we have a transversal L which is intersecting these two lines. So this form a system which is forming total 8 angles, which are named here: angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7 and angle 8. So these are the 8 angles formed by these two parallel lines when a transversal intersect them. Okay, so the angle 1, angle 2, angle 7 and angle 8, which are the outside angle, which is angle 1, 2, 7 and 8. These angles are called exterior angle. Okay, which are outside of the transversal, while the angle which are inside of the transversal, that is angle 3, 4, 5 and 6, that is 3, 4, 5 and 6 are called interior angle because these angles are between the parallel lines. Okay, they are inside the parallel line, that's why they are called interior angle, and these 4 angles are outside of the parallel line, so they are called exterior angle. Okay, next we have corresponding angles. Let me draw that figure again here roughly. We have two parallel lines and a transversal to them. Okay, we have this transversal. It is making 4 angles, which is angle 1, 2, 3. Here these 4 angles, then we have 5, 6, 7 and 8. Okay, now first type of angle, it is corresponding angle, that is angle 1 and 5. So these two angles, angle 1 and angle 5, then angle 2 and angle 6, similarly angle 3 and angle 7 and angle 4 and angle 8. These are the 4 pair of corresponding angle made by when a transversal falls on two parallel lines. Okay, then we have alternate interior angle. Alternate interior angle means angle 4 and angle 6 and angle 3 and angle 5. These angles are called alternate interior angle. Okay, then we have alternate exterior angle, the angle which are angle 1 and 7. You can locate this angle in this diagram. Okay, angle 1 and angle 7 similarly, or you can see it from here, angle 1 and 7 and angle 2 and 8, angle 2, this one and angle 8. These are angle are called alternate exterior angle. Okay, then we have interior angle on the same side of the transversal, which is angle these 4 and 5 and these 3 and 6. 4 and 5 and 3 and 6, these are called the interior angle on the same side of the transversal. Okay, so we have total 6 types of angle. First is exterior angle which are outside, then we have interior angle which are inside the parallel lines, then we have corresponding angle which are written here. We have 4 pair of corresponding angles, then we have alternate interior angle, we have 2 pair of alternate interior angle, which is 4 and 6 and 3 and 5. Then we have alternate exterior angle, which are again 2 pair, which is 1 and 7 and 2 and 8. Then we have interior angle on the same side of the transversal, which is 4 and 5 and 3 and 6. Okay, so these are the 6 type of angle formed by a transversal when it fall on two parallel lines. Now based on this we have certain axioms and then theorem, so we'll now discuss them. First is axiom 6.3. It says if a transversal intersect two parallel lines, we have a transversal intersecting two parallel lines, then each pair of corresponding angles is equal. Okay, so if a transversal falls on a parallel line, then each pair of corresponding angle is equal. Corresponding angles are these four pairs. These four pairs are the corresponding angles. That means we have angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7 and angle 8. This implies that the corresponding angle, that is angle 1, is equals to angle 5, angle 2 is equals to angle 6, angle 3 is equals to angle 7 and angle 4 is equals to angle 8. Okay, that's what this axiom says. If a transversal intersect two parallel lines, then each pair of corresponding angle is equal, which implies that angle 1 is equals to angle 5, angle 2 is equals to angle 6, angle 3 is equals to angle 7 and angle 4 is equals to angle 8. Okay, next we have axiom 6.4. This axiom 6.4 is the converse of axiom 6.3. Converse means is the reverse of the theorem, sorry, axiom 6.3. It says if a transversal intersect two lines. Okay, see here he is not just talking about the parallel lines, he is just saying if a transversal intersect two lines such that a pair of corresponding angle is equal. That means at least one pair of corresponding angle has to be equal, then two lines are parallel to each other. Okay, it is saying that if out of these angle, if any one pair of corresponding angle, okay, a pair of corresponding angle is equal, then these two line has to be parallel. Okay, that's what this axiom 6.2 says. It is saying that even if one corresponding angle, let's say if angle 1 is equals to angle 5, okay, so there's a one corresponding pair of angle. If at least one pair of angle is equal, then the line A will be parallel to line B. Okay, that's what this axiom 6.2 is saying. So 6.3 is saying if lines are parallel, so we are given that lines are parallel. So if lines are parallel, then corresponding angles will be equal. While the 6.4 says if corresponding angle is equal, then lines has to be parallel. Okay, moving ahead to the next one. Now we have theorem 6.2. The theorem 6.2 says if a transversal intersect two parallel lines. Okay, it's talking about a transversal intersecting two parallel lines. So the lines given here are already parallel. Okay, then each pair of alternate interior angle is equal. Okay, if a transversal intersect two parallel lines, then each pair of alternate interior angle has to be equal, which means alternate interior angles are, we have angle 1 here, angle 2, angle 3, angle 4, angle 5, 6, 7 and 8. So if a transversal intersecting parallel lines, if these two lines are parallel, it's given that these two lines are parallel here, then the alternate interior angle, that means angle 4 will be equals to angle 6 and angle 3 will be equals to angle 5. Okay, these are the two pair of alternate interior angle. It's when the lines are parallel. Okay, so we'll write, you can write if A is parallel to B, if A is parallel to B, then angle 4 will be equals to angle 5 and angle 3 will be equals to angle, sorry, 4 will be equals to 6 and 3 will be equals to 5. Okay, similarly now we have theorem 6.3, which is the converse of theorem 6.2. It says if a transversal intersect two lines, again you can see he's talking about only lines, not the parallel line, such that a pair of alternate interior angle is equal. So it's if the one pair of alternate interior angle is equal, then line has to be parallel. Okay, that means if angle 3 is equals to angle 5, which are the alternate interior angle, and if one pair of them is equal, then the line has to be parallel. That means A has to be parallel to B. Okay, that's what the theorem 6.3 says. Okay, so both theorems are, if lines are parallel, if this AB is parallel to CD, then alternate interior angle will be equal, or if alternate interior angle is equal, then line has to be parallel. That's what these two theorems says. Moving ahead to next one, we have theorem 6.4. It says, if a transversal intersect two parallel lines, if a transversal intersect two parallel, again it's talking about a transversal intersecting two parallel lines, then each pair of interior angle on the same side of the transversal is supplementary. Supplementary means their sum has to be equals to 180 degree. Okay, so this it's saying, let's name the angle first. 1 2 3 4 5 6 7 and 8. Okay, so it is saying that if a transversal intersect parallel line, that means these two lines are parallel. If AB is parallel to if A is parallel to, we have to write this like this, line AB is parallel to line CD. Similarly here also, this is AB parallel to CD. I think here also, yes, we have already done this. AB is parallel to CD. Here AB parallel to CD. Okay, if AB is parallel to CD, then the sum of these two angles, that is angle 4 plus angle 5, has to be 180 degree. Similarly, angle 3, these two, plus angle 6 has to be equals to 180 degree. That means they has to be supplementary angle. Okay, next theorem is 6.5. It says, if a transversal intersect two lines, okay, this time he is talking about only lines, such that a pair of interior angle on the same side of transversal is supplementary, then line are parallel. Okay, so this is converse of theorem 6.4, which says, if one pair of interior angle on the same side of a transversal is supplementary, that means if angle 4 plus angle 5 is equals to 180 degree, then line AB has to be parallel to line CD. Okay, that's what these two theorems says. This one is, if lines are parallel, then the interior angle on the same side will be supplementary, or if the interior angle on the same side of the transversal is supplementary, then line has to be parallel. Okay, that's what this theorem says. Then the 6.6 theorem, it says, line which are parallel to the same line are parallel to each other. That means if this L is parallel to M and N is also parallel to M, so this will implies that L and N are also parallel. That means if line L is parallel to M and M is parallel to N, so both are parallel to M, this implies that then L has to be parallel to N. That's what this theorem says. Lines which are parallel to the same line are parallel to each other. So if one line is parallel to the second line, and third line is also parallel to second line, then 1 and 3 are also parallel. Okay, so these are the few theorems. Based on this, we have chapter 6, lines and angle, and exercise 6.2. so the first question here is, in figure 6.28, find the value of angle X and Y, and then show that AB is parallel to CD. So first we have to find the value of X and Y, then we have to also prove that AB is parallel to CD. Okay, so let's start writing its answer. This is answer number 1. First we will write the given part. Given here is two lines AB and a transversal. Let's name it PQ. Let's write P here, Q, R and S. Okay, so let's write given in two lines, we are not given that these two lines are parallel, we have to prove that these are parallel. So write two lines AB and CD having a transversal PS intersecting the two lines at Q and R respectively. Okay, so these are the information that we have two lines and they are intersecting. We have two lines and there is a transversal PS which is intersecting the two lines at Q and R respectively. Okay, also we are given the measure of two angle, and angle PQA is equals to 50 degree, this one, and we are also given angle CRS is equals to 130 degree. Okay, so first we'll write the to find is X and Y, and we also have something to prove, which is to prove is AB is parallel to CD. To prove is AB is parallel to CD. So write its first solution. Okay, from the figure you can see that angle CRX, this one, angle CRX and angle DRQ, these two angles are alternate interior angle. Okay, so we'll write as line PS and CD are intersecting at R, as line PS and CD are intersecting at point R, therefore the angle CRS will be equals to DRQ. It will be equals to DRQ. Why they are equal? Because they are vertically opposite angles. Okay, CRS is given which is 130 degree, so DRQ is equals to 130 degree. That means, and DRQ is given as Y, so the value of Y is 130 degree. Okay, so we got the value of this Y. Now we have to find the value of X. So now write as line AB, we will take this ray PS, and we have PS is a line and we have a ray, this ray OA standing over it. So write as ray QA is standing on line PS, therefore the sum of angle PQA and AQR, the sum of angle PQA plus angle AQR has to be equals to 180 degree. This is axiom 6.1, which says if a ray stand on a line, then the sum of two angles so formed is 180 degree. So angle PQA is given, which is 50 degree. Okay, angle PQA is given here, which is 50 degree, and we have to find angle AQR equals to 180 degree. So angle QR, which is also given as x is equals to 180 degree minus 50 degree, and x is equals to 50 degree. Okay, so sorry, x is equals to 180 degree minus 50 degree, and x is equals to 130 degree. Now you can see from here that this angle y and angle x are equal, both are of 130 degree. And we have studied a theorem, which is theorem 6.3, which says if one pair of alternate interior angle is equal, then the line has to be parallel. Okay, so we'll write as the alternate interior angles x is equals to angle y, therefore line AB is parallel to CD. Okay, as alternate interior angle AB is equal to CD, therefore AB is parallel to CD. This is by theorem 6.3, which says if one pair of alternate interior angle is equal, then line has to be parallel. Okay, this is the answer of question number 1 of exercise 6.2. Now moving to the next question, we have in figure 6.29, if AB is parallel to CD and CD is parallel to EF, and we are given that the ratio of x and y is 3:7, we have to find the value of x. So first we'll write the given part. Let's write the answer number 2. Okay, first we'll have to write the given part. Given here is line AB is parallel to CD and CD is parallel to EF. We are given that AB is parallel to CD and CD is parallel to EF. Also that the ratio of Z and Y, that is Y to Z, is 3:7, and we have to find that the value of angle x. Okay, so let's write a solution. Let me explain how we're gonna do this. What we are aiming here is, we are given the value of this y and z, and we have to find the value of this x. Okay, also the ratio of these two angles is given, so we'll find this angle, and the angle here and this angle has to be alternate interior angle, right? And they has to be equal because these two lines are parallel. Okay, so first we are going to do this. So let's write, let's give this figure name, this ray as P, Q, and the points as R, S, and T. Okay, the transversal is given name as PQ, and the points are R, S, T, where it is intersecting the three given lines. Okay, so let's start. Since CD is parallel to EF and PQ is a transversal. Okay, in figure CD is parallel to EF and PQ is a transversal, then or therefore the angle CST, this angle CST, this one has to be equals to angle STF. Angle CST will be equals to angle STF. Okay, CST will be, since this angle is y, so this angle will be 180 minus y, so CST will be 180 degree minus angle y, while STF is given as angle Z. Okay, so we got that this, if you move this y onto this side, will be 180 equals to this minus z will become plus, sorry, minus y will become plus y, so z plus y is equals to 180, while we are given that the ratio of z is to y is 3 is to 7. Okay, sorry, y is to z is 3 is to 7. So from here we can find out that since y ratio z is 3 ratio 7, so let assume them to be in same ratio as, let's take y equals to 3a and z equals to 7a. Okay, then putting this value in this equation, let's name it equation 1. Now in equation 1 we have, let's use these values in equation 1. At the place of y will write 3, we have this, at the place of y will write 3a, at the place of z will write 7a equals to 180, or from here a will be 10a equals to 180, or wave a will be equals to 180 degree divided by 10 equals to 18 degree. So y will be, y which is 3a will be 3 into 18 degree equals to 54 degree, while z will is 7a, that means 7 into 18 which is equals to 126 degree. Okay, so these are the value of x and y. Now we can easily find the value of, sorry, these are the value of y and z. Now we can easily find the value of x, because as these two lines are parallel and x and y are the angle on the same side of the transversal, so their sum will be 180 degree. Okay, so all right, since AB is parallel to CD and PQ is a transversal, therefore the sum of angle ARS, this angle ARS and RSC, an angle RSC will be equals to 180 degree. This is by the theorem 6.4. Okay, this is theorem 6.4, which says the sum of the angle on the same side of transversal is 180 degree. Okay, so we have got this angle RSC, which is angle y. Angle y is, we got the value of angle y as 126 degree. So this ARS is denoted by x, and RSC is angle y, which is 54 degree equals to 180, or x will be equals to 180 minus 54 degree, and this will result into x equals to 126 degree. Okay, that's the answer for the question number 2, that the x is equals to 126 degree. Okay, I hope you understood this. It's very simple. Now moving to the next question, we have in figure 6.30, if AB is parallel to CD and we are given that these two lines AB and CD are parallel, then we have EF is perpendicular on CD. This EF is perpendicular on this CD. Okay, so that means this angle here is 90 degree. Then GED is angle GED, this complete angle is 126 degree. Okay, then we are given, we have to find three angles, which are angle AGE, this angle, then angle GEF, this part of angle, and angle FGE, it means this angle. So we have to find these three angles. So first write the given part. Answer number 3 given here is we are given that AB is parallel to CD and EF is perpendicular on CD, and we are also given that angle GED is 126 degree. Okay, and we have to find here the three angles, which are angle AGE, angle GEF, and angle FGE. Okay, let's try its solution. Solution is simply, as we are given that this angle is 126 degree, so and AB and CD are parallel and GE is transversal, so this angle will also be of 126 degree because they are alternate interior angles. So we'll write, since AB is parallel to CD and this GE is a transversal, GE is transversal, therefore the angle AGE will be equals to angle GED because they are alternate interior angle, and this is by theorem 6.2, which says if the lines are parallel, then the alternate interior angle will be equal. Okay, so we are given GED is 126, therefore AGE will also be equals to 126 degree. Okay, so out of these three angles we got the angle AGE, this one. Now we have to find the next angle. Now we have to find this, and we can find this angle GEF. This GEF will be this 126, which is a complete angle, minus this 90 degree. Okay, so now angle GEF will be equals to angle GED minus angle FED. GED is given, which is 126, and FED is 90 degree, so the result is 36 degree. So GEF, this angle is 36 degree, this one is 126 degree. Now we have to find only one angle, which is this one. Now you can see this is a line and this GE is a ray on it, so the sum of these two angles has to be 180 degree, so we'll use that. Now as ray GE is standing on line AB, we can write this as ray GE therefore this sum of the two angles so formed, which are angle AGE and FGE. Angle AGE plus angle FGE has to be equals to 180 degree. Okay, this is axiom 6.1. that if a ray stands on a line, then the sum of the two angles so formed is 180 degree. So AGE we have already calculated, which is 126 degree, plus FGE is equals to 180 degree. From here, angle FGE will be equals to 180 degree minus 126 degree, which result into 180 degree minus 126 degree is 54 degree. So the answer of FGE is 54. So we got all angles. These are the three angles which we were asked to calculate. Okay, so that's the answer of question number 3. Now moving to the fourth question. Question number 4 is, in figure, this PQ is parallel to ST. Angle PQR, this is 110. Angle RST is 130. We have to find the angle QRS. We need to find angle QRS. Okay, so let's start. Answer number 4. first we'll write the given here is PQ is parallel to ST and angle PQR is equals to 110 and angle RST is equals to 130 degree. Okay, we have to find an angle which is angle QRS. So before the start of the question, what we're going to do is we'll do a construction. So first we'll write construction. Construction is draw a line let's give that a name AB parallel to PQ and ST through R. That means we will draw a line, this one, it's a line, we have given this name as AB, A here and B here, and this is parallel to also PQ and ST. Okay, since both are already parallel, so this line will be parallel to the both line. Now what we're gonna do is, let's first write the solution. Solution for this one will be very simple. Now you can see these two lines are parallel and this SR will be transversal, so the sum of the two angles on this side will be 180 degree. Similarly, this PQ and AB are parallel and the sum of the two angles on this side will also be 180 degree. Then, and the sum of all the angle at a point is, all the angle at a point on a line has to be 180 degree. That means the sum of these three angles has to be 180 degree. So by subtracting these two angles from 180, you will get the value of this angle. Okay, so let's start its solution. So first we'll write, as AB is parallel to PQ, since PQ parallel to AB and transversal is QR and QR is transversal, therefore the sum of angle PQR and the given angle QRA plus angle QRA has to be 180 degree, and this is by theorem 6.4. This theorem 6.4, which says the sum of the angle on the same side transversal is 180 degree when the lines are parallel. Okay, so PQR is already given, which is 110 degree, and angle QRA we are trying to find, which is equals to 180 degree. So the angle QRA will be 180 degree minus 110 degree, so the result is 70 degree. Okay, similarly since AB is parallel to ST and SR is a transversal, since AB is parallel to ST and SR is transversal, therefore again using the theorem 6.4, the sum of these two angles will be 180 degree. That means angle RST and angle SRB, angle RST plus angle SRB will be equals to 180 degree, again by theorem 6.4. okay, RST is given, which is 130 degree, and SRB we are trying to calculate equals to 180 degree. So the angle RB will be equals to 180 degree minus 130 degree. Okay, so angle SRB will be equals to 50 degree. Okay, now as we know the sum of all the angle, the sum of all the angles at a point on a line, is 180 degree. That is, the sum of angle QRA plus angle, which we have to find, angle QRS plus angle SRB is equals to 180 degree. QRA we have calculated, which is 70 degree, so the QRA is 70 degree. Angle QRS we have to find, and angle SRB is 50 degree, equals to 180. So angle QRS will be equals to 180 degree minus this 70 plus 50 is 120, and 180 minus 120 is 60 degree. So the answer of angle QRS is equals to 60 degree. Okay, so that's the answer for the question number 4. Now moving to the next question, we have question number 5. It says in figure 6.32, if AB is parallel to CD and angle APQ is 50 degree, find and angle PRD is 127 degree, find X and Y. So as this angle is given 127, the sum of these two angles also has to be 1 into 127, because these two lines are parallel, and this PR is a transversal. Okay, so we can easily find these two by subtracting it from 127. You will get the value Y, and angle, this angle and this angle are alternate interior angle, so they has to be equal. So let's write it. Answer number 5. First we will write the given. Okay, given here is AB parallel to CD, and the two angle are given, which is angle APQ is equals to 50 degree, and angle PRD is equals to 127 degree. Okay, and we have to find that angle X and X and Y. So let's write solution. Solution for this one will start with we'll take, since AB is parallel to CD and PQ, this one PQ is a transversal, PQ is a transversal, therefore angle PQR will be equals to angle APQ, because they are alternate interior angle, and this is by theorem 6.2, which says if lines are parallel, then the alternate interior angle of a transversal are equal. So PQR we have to find, which is X, and APQ is given, which is 50. Okay, now moving ahead, so right, similarly, since AB is parallel to CD and PR is transversal. Okay, every time you have to write the name of parallel lines and the name of transversal. Okay, so AB is parallel to CD and PR is a transversal. Therefore the angle PRD and angle APR will be equals. Angle APR will be equals to angle PRD. This again by theorem 6.2. okay, the alternate interior angle will be equal of a transversal. So APR here is 50 plus APR can be written as the sum of angle APQ and QPR. This can be written as APQ plus angle QPR, and PRD is given, which is 127. APQ we have calculated here, which is APQ is 50, and we are calculating PQR, which is 127. So angle QPR is actually y. Let's write y here is 127 minus 50, so this will be 77 degree. Okay, now next question is, in figure 6.33 PQ and RS are two mirrors. So we have the two mirror PQ and RS placed parallel to each other. That means these two mirror, or you can say these two lines, are parallel to each other. We have an incident ray AB which is coming from here. AB strike the mirror PQ at point B, and reflected ray move along the path BC, which is this one, and strike the mirror RS at point C and reflect back to the part CD. You have to prove that AP is parallel to CD. So let's write its answer, number 6. First we'll mention the given part. This answer number 6. Let's write the answer number 6. First we will write the given part. Given here is two mirrors PQ and RS placed parallel to each other, and an incident ray strike the mirror PQ and RS at points B and C. Okay, we have to prove this was the given part. We have to prove that AB is parallel to CD. That means these two rays AB and CD are parallel. Okay, we have to prove this. So before the proof, we'll do a construction. So let's try the construction. Okay, construction here is, draw two normals construction is draw two normals which, let's draw the normal first. We have this, from the point B we'll draw a normal like this, let's name it point BN here, and from point C we'll draw another normal, let's name it BM here, CM here. So draw two normals BN and CM from the mirror mirrors PQ and RS. Okay, now let's start its proof. Okay, in this figure you can see that we have drawn this perpendicular. If you extend this perpendicular, they will also fall perpendicular on the its opposite mirror. Okay, similarly this CM will also fall the perpendicularly on this mirror BN, and it is making four angles. The angles are, let's name it angle 1 here, angle 2 here, angle 3 here, and angle 4 here. So they are making four angles. Okay, so let's see here. Since the normal BN and CM are the normals to the plane mirror PQ and RS respectively. Okay, B and CM are the normal to the mirror PQ and RS respectively. So this PN is perpendicular on PQ, this ray BN is perpendicular on PQ. Similarly, or you can say CM is perpendicular on RS, and we are given that in the question that PQ and RS are parallel. So therefore the line BN will be parallel to CM. This is because these are the perpendicular between the parallel lines and they has to be parallel to each other. Okay, so perpendicular between the parallel lines are parallel to each other, therefore BN and CM are parallel. So since BN and CM are parallel, and this ray BC will be a transversal, and BC is a transversal, therefore the alternate interior angles, so we have these two parallel and BC is transverse, so the alternate interior angle 2 and angle 3, these two angle 2 and 3 has to be equal, so therefore angle 2 will be equals to angle 3. Okay, let's name it equation 1 here. And from law of reflection we know that angle of incidence is equals to angle of reflection. From law of reflection we have angle of incidence is equals to angle of reflection. You must have studied this in your physics portion, right? That angle of incidence equals to angle of reflection. That means in these cases angle 1 and 2 will be equals, and also the angle 3 and 4 will be equal. This is from the law of reflection which you studied in the your physics portion. Okay, that means angle 1 is equals to angle 2 and angle 3 is equals to angle 4. Now what you have to notice here is that angle 1 and 2 are equal, 1 and 2 are equal, angle 3 and 2 are equal, angle 3 and 4 are equal. That means if 1 is equals to 2 2 is equals to 4, 3 is equals to 4. This implies that, let's name it equation 2. So write from equation 1 and equation 2 we get what we get, that angle 1 is equals to angle 2 is equals to angle 3 is equals to angle 4. Okay, hence if we add this angle, if we add angle 1 and angle 2, angle 1 plus angle 2, their sum has to be equal to the sum of angle 3 and angle 4. Because they are equal, their sum will also be equal. So the sum of angle 1 and 2 is angle ABC. The sum of angle AB is 1 and 2 is equal to angle A, B and C, while the sum of angle 3 and 4 is equals to angle B, C, D. Okay, so and which are the alternate interior angle. These two angles are alternate interior angle. So since the alternate interior angle are equal, therefore by the theorem 6.3, these two line AB and CD has to be parallel. Okay, so since these are two equal and they are alternate interior angle, so this implies this implies that AB is parallel to CD, and this is by theorem 6.3. Okay, so now you must have noticed that in every question we have used many theorems. Okay, so that means the learning and the remembering is of the theorem is very important. You should learn all the theorem and you have to remember them, because we are going to use them time to time. Okay, so with this we have completed the question number 6 of exercise 6.2, and we have completed the exercise 6.2. Okay, I hope you understood all the question. Now what you have to do is you have to practice all this question by yourself so that you can understand them better. Okay, so that's all for today's class. Thanks for joining here. Thank you.